All right, guys, we're going to do a little bit of work with FRQ 3 and 4. I want you to go ahead and pause the video and try these two. So this one I want you guys to solve, and then this one I'm going to label this as m of x equals. And I want you to simplify this, and I want the answer in terms of sign. So go ahead and pause the video, try these two. There will be more later to try. All right, so let's go over these two, and then I'll post the next slide after that. So we're adding logs. Anytime we're adding logs, we know we got to multiply whatever's inside of our log. So x and 4 are going to get multiplied. But when you do that, don't just write x times 4. We're going to go from 2 logs down to 1 log. So it's log base 3 of this right here, and then equals 2. That's our first step. The second step, to solve a log equation, unless there's 1 log on both sides, we've got to convert to an exponent. Okay, so we get rid of the word log. The base of the log is now the base of our exponent, and these two things are switching here. Okay, so our exponent is now 2, and this is x times 4, or 4x. All right, from there, 3 squared is 9. So 9 equals 4x, and then just divide the 4 over, so x is 9/4. And it's okay if it doesn't simplify. You can leave it like that. All right, so that's the first one. That's our answer. This one over here, it's a little tricky. So first I can replace cosecant of x with, and I want to start by writing what the function's called, which is m of x. Okay, so m of x equals, cosecant of x is defined as 1 over sine of x. And we should recognize that 1 minus cosine squared is equivalent to sine squared of x. All right, don't forget the x's here. Now, don't just assume things cancel. We've got a fraction and a fraction, so we want to keep, change, flip at this point. If it helps, you can put it over 1, so you know we're keeping this, we're changing to multiplication, and we're flipping this fraction. So I'm going to just work side to side. I could also go up and down and just connect with the equal signs. But I'm going to keep the 1 over sine. I'm going to change the division to multiplication, and I'm going to flip that bottom fraction into a 1 over sine squared. And so they don't cancel. This is like having x times x squared, so the bottom is going to become an x cubed, or in this case, a sine cubed of x. So it's going to be a 1 times 1 on top, so 1 over sine cubed of x. And that's our answer here. That's as simple as we can make that if we're leaving it in terms of sine. If it said in terms of cosecant, I'd make it a cosecant cubed in the numerator. Right? So that's it for that one. Again, we don't want to leave here. We don't want to leave this here. Because it can be simplified more. All right, so that was that one. All right, now you guys are going to try to simplify this as much as possible. And assuming you've done that now, you pause the video and did that, I'm going to simplify this. So k of x equals anything that's a positive. We're going to go from 4 logs down to 1 log. Anything that's a positive is going to go in the numerator, and anything negative goes in the denominator. So let's see what goes in our numerator here. 2 should go on top. And then we also had a positive over here at 2x cubed, so that goes on top. But be careful, it's not addition anymore, it's multiplication now. We also need to move that 3 up here, and then anything with a minus in front is going to go in the denominator. So it's going to be x plus 1, 2 the third goes in the bottom, times x. It's not minus x anymore, it's times x. All right? Now, I cannot cancel this x cubed with that one. I can, however, simplify x to the third over x, because the x plus 1 means I can't simplify with anything that's not an x plus 1. All right, so k of x equals this, equals log of, so I'm going to go and multiply the 2's. I'm going to get a 4 on top. And remember, x cubed over x, we subtract the exponent, so now there's an x squared on top, divided by, we still have that x plus 1 cubed. And this is really small, but I know a surprising number of people put their equal sign right here. It needs to be in front of the log, not in between the log and what's inside the log. Okay, so it should look like this right here. And that would be the most simplified answer. You do not need to do x plus 1 times x plus 1 times x plus 1. Okay, you would have to do a ton of distributing. That is not more simple than this. And no, you cannot distribute an exponent to the x and the 1. It's not x cubed plus 1. Does not work. Okay, we leave it like that right there. All right? All right, a couple more to look at. Then this will be for FRQ4. So again, go and pause the video here. All right, so if you've got an inverse trig function, these are easier than they look. We want to start by getting this inverse trig function by itself. Ignore the inside. So I'm just going to move that 3 over. Right now it's being multiplied. We're going to divide it over. So I was going to say 2 pi over 3 equals arc cosine of x over 2. The next thing I want to do is I want to separate this inverse cosine, this arc cosine, from x over 2. So the way I separate it is I move it to this side. I'm not dividing it, I'm just moving it. But when inverse or arc cosine, or any inverse trig function switches sides, it becomes a normal trig function. So now it says cosine of 2 pi thirds equals the inside, which is x over 2. Well, the x coordinate at 2 pi over 3 on the unit circle is -1/2. So -1/2 equals x over 2. And we're not done solving for x yet. X is not by itself, it's being divided by 2. So I'm going to multiply both sides by 2, and we would get x equals -1. All right, so that's how we do that one. And then this one right here, we got to use our exponential properties. Okay, I do not multiply the 8s. I do not divide the 8s. I don't do 8 to the 4th. Here's what I'm going to do. I'm either going to multiply that 8 to the 4th over, which would be fine if you did it like that. That might be the easiest in this case. I'm going to go ahead and do that actually. I'm going to multiply the 8 to the 4th on both sides. So the left-hand side becomes 8 to the 4th equals 8 to the x times 8 to the 5x. Now if you didn't, it's a little trickier. Later you're going to have to call that an 8 to the 0 for this to really work, or convert it into a log later on. But this is the easiest way to come up with the answer. Now, I'm multiplying like basis. I don't multiply the 8. I add the exponents. Not multiplication, it's addition when that happens. So 8 to the 4 equals 8 to the, if we add the exponents, 1x plus 5x is 6x. Well, now we have the case where both bases are the same. And so if we set the exponents equal to each other, we can solve for x. 4 is equal to 6x. Divide the 6 over, 4 over 6 equals x, and you are supposed to simplify on FRQ4. So don't leave it as 4 over 6, write it as 2 over 3 equals x. And that would be full credit right there. Again, there's other ways to solve this, but unless you're getting 2/3, you're not quite doing it correctly, or maybe you're not going far enough into the process there. All right, so that's it for FRQ4. I want to very briefly talk about FRQ3. I'm not going to do a whole problem with this one, so I just want to go over a few things. Obviously, we want to try to get our coordinate points correct on this sine or cosine function, but here's what has to happen. The x's must be increasing by the same amount each time. So if you have no clue, you might just want to write 0, 1, 2, 3, 4, or something similar to that. Okay? I'm not giving you guys anything here, so you're not pausing this one. I'm just talking about it. The y's. So if you have no idea, make sure that each y is equidistant. So the y values will go down, down, up, up by the same amount each time. So here's a good guess. Again, try your best to actually get this right, but maybe this is 10, and this is 0, and this is -10, right? So it went down by 10, down by 10. This doesn't have to be 0. I'm just making up numbers. And then up 10, so this is 0, and these two numbers should be the same. And then up another 10, right? And these two numbers should be the same. Okay, if we can at least get our x's increasing by the same amount, and our y's going down by the same amount, and then up by the same amount, we can get the next points here, which is for A, B, C, and D. All right, so to get, I like to start with D. D is the midline. Well, what does the midline go through? It goes through this point and this point. What do they have in common? They have a y value of 0. So D would be 0 here. A, remember A is amplitude. Amplitude is a distance. It's the distance from the midline to the top or to the bottom. Well, from the midline, I could go, look at our y values here. I could go up 10 or I could go down 10. So A is either positive or -10. Don't put both, just pick one. I'm going to go with positive 10 here. All right. Now B is always 2 pi divided by the period. All right, so we got to look at what we put for our period. Our period is our distance and our x values from the first max to the second max. Or if we had a different graph from min to min, etc. All right, so what's the distance between this x coordinate and this one? Well, it's 4. So that's our period. So b is just going to be 2 pi divided by 4. And I get pi over 2. All right, and then c, it depends on if it's a sine or cosine function. So I'm just going to put a question mark here. Again, that one's tough to get. But it depends if you want the positive or a negative and if it's a sine or a cosine. All right. Now, that's probably 1.5 points if I didn't get C. If you don't know C, a good answer or a good guess is always 0. It might be 0, it might not be. But again, I got 3 out of the 4. That'd be 1.5 points. Now, the only other thing we got to know here is for each interval, is the function positive or negative, increasing or decreasing? Not its rate of change. This part's, I think it's C part 1 is not asking about its rate of change. C part 2 is. We're only going over C part 1 right now. All right, so in this section, we should be able to label the graph as either positive and increasing, positive and decreasing, or negative and increasing, negative and decreasing. So I want you guys, for each of these 4 parts, I want you to pause the video and see if you can figure out, which of those 4 is it, right? Is it positive and increasing, positive and decreasing, etc.? All right, so for this, you should have gotten positive and decreasing. Why is it positive? Well, the y values are positive in between 0 and 10. It's decreasing because it's going down to the right. Then, for this portion, the y values are now negative, and the function is still decreasing. It's still going down to the right. For this part, the y values are still negative. They're in between 0 and negative 10. 0 and negative 10. But now the graph's going up. So it's negative and increasing. And then lastly, our y values would be positive, and the graph's going up, so positive and increasing. Okay? Now, it's not to say that this interval is always negative and increasing, right? It's always increasing, but based on my y values, it's negative. All right? So it depends on the y values of what you have on yours. All right? So that is everything. C part 2, I kind of view as almost like extra credit. If we get it, we get it. If we don't, not a huge deal. All right? But thanks for watching, guys, and best of luck on your exam on Tuesday. Stay flawless.